Okay guys, what we have here is a function, okay? This function says f of x equals 6x minus x squared. I need to find f0, f1, f2, f3, f4, f5, f6. The way you do that is, f of x means whatever the x value is, you exchange it for whatever value they give you. You can do it the long way where you say, look, f0 is 6 times 0 minus 0 squared. And then you can do f1 is 6 times 1 minus 1 squared. I think I pretty much just wrote down in your solutions, I said use the table function in your calculator. It's much quicker. So what I just do is this, shift table function, then enter in 6x minus x squared, and start at 0, end at 6, and what you get is 0, 0, 1, 5, 0, 0, 1, 5, 2, 8, 3, 9, 4, 8, 5, 0, 6, 0. So, yeah, fill it in as you go along. Yeah. So guys, you're on page 22, I think. Okay. So guys, what we have here is, you can see that each point I got, 0, 0 is here, 1, 5 is here, 2, 8 is here, 3, 9 is here, 4, 8 is there, 5, 5 is there, 6, 0 is there. All the points I got are graphed on this graph here, and if I was to graph it up, if I was to draw it out, I'd get the same mark that's on the board. Now what they're going to ask you next is, they ask you this here. Use the trapezoidal rule to estimate the area of the region enclosed between the curve and the in between the curve and the x-axis in the given domain. Okay. Does somebody have a table on page 12 of your notes? Okay. What you'll see is a diagram, something like this. The diagram will be just a random shape like that, and then what it tells you on what it tells you about this random shape is this. It tells you that the first one is y1, and you have a gap of, like, it's the same gap every time, so you have a bunch of vertical lines, okay? And what it will also say is it will label them. It labels the second one y2, the third one y3, fourth one y4, and then it just keeps going on, and then it calls the last one yn. Everybody happy with that? Yn. Now, what it then says is, it has something called the trapezoidal rule underneath. The trapezoidal rule is your h value over 2. It's basically your y1 value plus your yn value plus 2 times y2 plus y3 plus y4 ... Okay, you got to make sense of this rule. That's what's in your tables, but you got to make sense of it. Realistically, what it means is this. y1 is your first height. yn is your last height, and then 2 times everything that's in between. So 2 times the remaining. So does everybody get that? y1 is your first height, yn is your last height, and 2 times your remaining. What is the h value? It has the h values located down here. For this particular diagram, my h value would be 3. But I have to check what the diagram above does, okay? So look at the diagram above. The h value for this is, it goes up in ones, doesn't it? Although it's 2 blocks, each 2 blocks is worth 1. So my h value is worth 1. What is my initial height? What's my first height off the ground? 0. My first one is 0. So, and what's my last one? Last one is also 0. And the h value is a half. Now, what about the rest of them? This one is a height of 5. The next one, a height of 8. The one after that, height of 9, a height of 8, and a height of 5. I have to do 2 times the remaining. So 2 times 5 plus 8 plus 9, 1 over 2. Plus another 8 plus another 5, close bracket. So guys, what happens next is this. It's going to be a half, and you just put all that into the calculator. I think that's going to turn out to be 70. So a half times 70 is 35. your trapezoidal rule gives you 35. Is that okay? Alright. Now, the mean distance from the Earth to the Sun is this much here. I'm going to write each of the following. Okay, never mind. So, correct the two decimal places. Put root 5 into your calculator, you get 2.24. Put this into the calculator, you get 2.86. Put tan 70 into your calculator, provided your calculator says D on the top. Please make sure it says D, otherwise you'll get a different number. In the event that you don't have D on top, as an example, instead of D I have R. I write down tan 70. Tan 70 is not correct. It's meant to be 2.75, it's currently 1.22. That means I'm in radian mode, not degrees mode. I press shift, setup. I then go back to degrees by pressing the number 3, press equals, it fixes the problem to 2.75. Okay? I then do 3 pi over 4, once again using the calculator to get 2.36. 250%? 1.0 is 100%. What does that mean about 2.5? What does that mean about 250? 2.5. Then this last one, you just got it. It's just basically entered into the calculator. It's going to be 1 plus fraction tenth, and then to the power of 10. And what you get there is that number there, so 2.59. Now that I have that done, I'm asked to mark 5 of the numbers in the table on the number line below and label each number. I'll start off with A. That's 2.1, 2.2, 2.3, 2.4, 2.5. Oh, wait a second. So I have to go up in twos. 2.1, 2.2, 2.3, 2.4. Everybody happy with that? So that's A. I'll do another one. F is pretty easy to do. That's 2 down. D will be easy to do because it's 2.6, 2.7, 2.8, 2.9. So 2.6, 2.7. Halfway between 2.7 and 2.8 will be point D. That's pretty easy to do. So I've done D, A, and F. I might as well do G because it's just underneath 2.6. So that there will be G. Do one more of them. I'll do B. That's 2.1, 2.2, just underneath 2.25. That will be B. Everybody happy enough with that? Just put it on the number line. Okay. This one here. 1 second. Now, okay guys. Quick revision on this exercise here. Ready? Excuse me. This one here, okay? If you look at the numbers here, just some rules I need to go over. 3 to the power of 2 multiplied by 3 to the power of 3 gives you 3 to the power of 5. Everybody remember that? 3 to the power of x by 3 to the power of 5 is 3 to the power of x plus 5. Similar rule to that. 3 to the power of 2 to the power of 3 is anybody? 3 to the power of 6. Likewise, 3 to the power of x to the power of 2 is 3 to the power of 2x. Sometimes you multiply, sometimes you add. You add when there's 2 big numbers. In general, you multiply when there's only 1 big number and 2 powers. That makes sense? That's revision of what you've already done. Now, what you can also do is this. It only works when the big numbers are the same. As an example, 3 to the power of x equals 3 to the power of 5. It's very obvious to see that x is the number 5 because they're the same big number as each other. In the question below, they're not the same number. So what you do is you convert the bigger number into the smaller number. There's a nice button that'll do that for you actually. If you look at the fact button in yellow, it's in yellow, which means you press the shift button to activate it. Shift fact, shift fact, okay, you actually press it afterwards, alright? So 27 equals, then you press shift fact. It turns the 27 into 3 to the power of 3. So 3 to the power of 3 is now in place for 27. Okay, now what rules do you do when you have 1 big number and 2 powers? The multiply rule, so it's 3 to the power of 6x equals 3 to the power of x plus 10. You then have to solve the formula 6x equals x plus 10. Move it over to your side. 5x equals 10. X will equal 2. What we have here, guys, is what is differentiation? Are you looking? What is differentiation? When you're asked to differentiate, what you do is this. We'll just do a quick small sample in the corner. When you have x cubed, it means you bring the 3 to the front and you take 1 away from the power, which turns into what? 3x squared. If I had x4, what would it turn into? 4x 3. Now, change that up a little bit. If I had a 5x cubed, yeah, I ignore the 5 and I just differentiate x cubed as I would normally. So what's the answer? 3x squared. What's 5 times 3x squared? That's it differentiated. Okay. Likewise, if I had to do another one like this, minus 7x4, just bring down the minus 7, and what happens when I differentiate x4? It becomes 4x3. What's minus 7 times 4? Minus 28x3. Alright, we're going to apply that knowledge to the question, okay? One last thing, if it's 5x, it differentiates into just 5. If it was 10x, it would differentiate into 10. If it was a minus 100x, it would differentiate into minus 100. Perfect. And any numbers on their own turn into 0. As an example, 5 on its own would differentiate into 0. Minus 100 would differentiate into 0. So there's different rules for different numbers, okay? And you're about to see all rules in play now. This one has a x cubed. It's 2 times the derivative of x cubed. What's the derivative of x cubed? When you differentiate x cubed? 3 to the front, take 1 away. Okay. Next thing, minus 3 times the derivative of x squared. What's x squared? 2x. Finally, differentiate a number? 0. Just quickly multiply that out. 6x squared minus 6x. That's it. You're done. This one, technically speaking, isn't on the course anymore, but they can still ask you it. So they could ask you. You just have to multiply it out first. After you multiply it out, then you differentiate. So let me show you. 2x squared times x cubed minus x plus 2 plus 3x into x cubed minus 1x plus 2. Finally, plus 1 multiplied by x cubed minus x plus 2. Long story short, I got to multiply the 2 by that, by that, by that. That's 3 numbers. I then have to multiply this one once, twice, 3 times. That's 6 numbers. And then finally, that, by that, by that. There's going to be 9 different numbers here. Okay? I doubt they're going to do it to you, but they can. So what happens is this. 2x to the power of, anybody? x2 by x3? x5. Addition. x2 by x3 is x5 when you multiply them. Alright, x2 by x1? 2x 3. I haven't differentiated yet, I'm just multiplying. 2x squared by 2? 4x squared. 3x by x cubed? 3x4. 3x by minus 1x? 3x squared. 3x by 2? 6x. 1 by x cubed? Just the same thing, isn't it? Now, how many x5s do we have? Just 1. How many x3s do we have? Or sorry, we have an x4 actually, now that I think about it. How many x3s do we have? So, 2 minus 2 plus 1? What's that? Huh? Shh. There's another one, is there? Another x3 somewhere? Oh, sorry, minus 1 x3, yeah. After that, guys, x squared. Just 2 of them, is there? Plus 1 x squared. And then after that, how many x's? Just the 1. Is there another one? 6x minus x, so plus 5x, and then plus 2. Now I get to differentiate. I haven't differentiated yet. So what happens when we differentiate these? This is good practice though. Differentiate it. The first one, bring 5 to the front, multiply by the number that's already there, take 1 away from the power, 10x4. Next one, 12x3. 4 multiplies by the number that's already there, take 1 away from the power. 3 multiplies by the number that's already there, take 1 away from the power. 2 multiplies by the number that's already there, take 1 away from the power. Does 5, and the 2 turns to 0, and you're done. Okay? That's question 5. I put an X through part C, no longer on your course. Okay? Yes. So what we get here next, guys, is diagram shows the graphs of a quadratic function. F of x equals x squared plus 3x minus 1. X is an element of R, which means x can be a fraction, it can be a decimal, it can be what it wants, okay? You have the line L1. L1 passes through the point 2, 0, and is a tangent to the curve at the point minus 1, minus 3. Now, what does a tangent mean? It means it only touches the curve once. Lines that aren't tangents are ones that either hit it twice or don't hit it at all. Everybody got that? Now, the whole point of differentiation is that at any given point, when you differentiate it, it will give you the slope of the tangent. As an example, if I differentiate and use x equals minus 3, it will give me the slope of the tangent that hits the curve at minus 3. If I differentiate and use x equals 1, it will give me the slope of the tangent. See where x equals 1? It will tell me what the slope of that tangent would be if it was a tangent. It just keeps telling you the slopes of tangents, okay? That's what differentiation is. So you'll have a generic curve of some variety, and differentiation will tell you how fast is it increasing at any given point on the graph. How fast is it going, okay? How fast or how it's increasing is called the slope, okay? So as a generic rule of differentiation, when you see the word slope, slope always means first derivative. Every time. Yeah? A turning point happens when what, guys? Turning points happen when the slope is 0. Turning points, if you see the word max or min, you write down first derivative equals 0. Find the first derivative, put it equal to 0, and then figure out what happens from there. Okay? So let's look at this question here and look at exactly what they want us to do. First of all, they gave us this here. They want me to find the slope of L1 using the slope formula. They want me to use the slope formula. I go to my tables on page 18. I write down the slope formula. This is geometry now. Geometry and trigonometry. Geometry can turn up in trigonometry, okay? So what happens next is I need to find two values to put into this equation here. So what two values are on L? I'd say that point is on L. That's the point minus 1, minus 3. Any other points on L? What about 1, minus 1? Everybody right with that? Then we have x1, y1, x2, y2. Fill them in. We get minus 3. What's that other one? Minus 1. Then we get minus 1. And then x1 is 1. I put that into my formula, and I get equals 1. Just put all of that into the calculator, and you get 1 as your answer. Okay? Now that you have that, it means the slope is 1. What's the slope of 1 actually mean? For every 1 across, you'll go 1 up. Does that happen here? 1 across, 1 up, 1 across, 1 up, 1 across, 1 up. It is a slope of 1, isn't it? Because it goes 1 across, 1 up, 1 across, 1 up, and you stay on that line. Find the derivative. Now here's where you can make easy marks. F dash x also means the derivative. What is the derivative of x squared plus 3x minus 1? What's the derivative, guys? Anybody? Derivative of x squared? 2x. Derivative of 3x? Just 3. Just derivative of 1? 0. And you're done, right? This here, see this fancy formula here? that will give you the slope at any point you want. Okay? As an example, if I want to find out the slope at this point here, what's the x value at this point here? I'll colour it in green now. What's the x value at this point here? Anybody tell me? What's the x value at the green point? -1. If I replace in -1 for x, because remember what I told you earlier, the first derivative is the formula for the slope. If I replace x with -1, it will tell me the value of the slope at that point. It's going to be -2 plus 3, which is equal to 1. That was also the slope we got earlier for the line L1. It will do this for any point you want. Okay? The line L2 is perpendicular to L1 and is also a tangent to the curve. Find the coordinates of the points at which L2 touches the curve. Where does L2 touch the curve? Okay. So, okay, I wrote down a quick note here. If I had a slope of 3/4, what's the perpendicular slope? Can anybody tell me? You turn it upside down and change the sign. Okay? In this particular question, the slope formula is 2x, was it 2x plus 3, yeah? I want to find the coordinates. What does that mean? How do I answer the question? I need to find an x value and I need to find a y value. I haven't answered the question until I get an x value and a y value. Where they come from, we have no idea at the moment. Okay? What we do know, however, is that the slope, our old slope, was 1. What does that mean about our new slope? Turn it upside down, change the sign, so the perpendicular slope is -1. That means that this formula here has to be equal to -1, because that formula represents the slope. Therefore, 2x plus 3 equals -1. Bring it over to the other side. 2x equals -4. This means x equals -2. I'm actually halfway towards my answer now. Now all I have to do is find the y value. What's the y value then? When x is -2, what's the y value? -2 and -3. -2, -3. See the way the slope was a -1? Look at the value here. If I drew a tangent here, the slope would be, see the way it's a -1 slope. It's going 1 across 1 down, 1 across 1 down. That's a tangent at that point there. Okay. Is that it for that question? Or is there more?